The combined gas law equation is the following. P1 times V1 over T1 equals P2 V2 over T2. So if you would like to solve for one unknown factor here, you would have to cross multiply. It depends on what variable you're looking for. What's important about this equation is that you can solve for temperature, pressure, volume, of course, either before the initial conditions or the final conditions. So let's look at a question right here. It says a sample of helium gas has a volume of 0.180 liters. So we start by saying that that's V. We don't know if it's V1. It's most likely if you start with it that it's going to be V1, 0.180 liters. Pressure, that's P1 of 0.800 atm. And the temperature of, which is T1 of 29. Now remember, in gases, we always convert to Kelvin. We need it in Kelvin. So it's very simple. All you have to do is add 273. So in this case, when you add the 273 to 29, you get 302. So again, must be in Kelvin. At what temperature will the helium have a volume of 0.0900 liters? So that's V2. And the pressure, which is P2 of 3.20 atm, or atmospheres. Now, what are we solving for here? We are solving, it says to you at what temperature. So we're looking for T2. That is X. So you're solving for T2. So to set up your equation would be P1 V1 over T1. P1 V1 over T1 equals P2 V2 over T2. Again, we're looking for T2 right here. So we'll make that in red so you can see what we have to do. So you need to cross multiply, meaning take T1 times P2 V2 and then T2 times P1 V1. So it's going to be P1 V1 T2 equals P2 V2 T1. Now, what are we solving for? We're solving for T2, so we divide each side by P1 V1. Again, this is basic arithmetic calculations. So this side cancels out, so you're left with T2 equals P2 V2 T1 over P1 V1. So all you have to do now is plug in. We can erase this side since we canceled it out, and now we're left with this. Now we need more space here because we have some numbers, so we'll put T2 right here. Okay, P2. It's right here, 3.20 atm. V2, 0.0900 liters. T1, 302. P1, pressure, initial pressure is 0.8. and V1 is 0.180 liters. So if you notice here, the units cancel out, the units of ATM and units of liters, we're left with K, which is the temperature. So when you do this calculation, you would like to, let's plug it in, let's show you how to do it. So you'd like to multiply the top and of course divide by the product of the bottom. So you have times 0.18. Okay, we have 3 sig figs in each of these, so we were supposed to maintain that, so we'll use blue. You get 604K. That's T2. Now, how do you know when to use this equation? Well, you're given initial volume and final volume. You're given initial pressure, final volume, final pressure, and you're given initial temperature, and you're looking for the final temperature. So that's how you rule out other equations if you encounter others. So this one is specific. You're looking for one of these, either initial or final volumes or temperatures or pressures.